Assalamualaikum and hello to everyone. So in this video, I will be discussing on one of the question from the chapter 2, okay, for the tutorial question. So we have answered in the previous video the A portion of the question, and now we will try to answer the B portion. Okay, so when we read the question, okay, so we know that the substance is a gas, okay, so nitrogen gas, okay, in a vessel, okay, undergoes the following processes, okay. So we have two processes here. So the first process is an isothermal compression process, okay. So we are given the values for pressure and volume at state 1, and also the pressure and volume at state 2. Okay, so and then we have the second process, the polytropic expansion. Okay, so here it gives us the equation PV by the power of 1.5. So 1.5 here refers to the index number, okay, n is equals to 1.5. Okay, back to its original volume. Okay, please be careful with this statement here, okay. It says back to its original volume, okay, so meaning that V3 here, okay, the volume for state 3 here is equal to the volume at state 1, okay, because at state 1 is the original state, okay. So two processes, okay. So the first thing the question asks us to do is to sketch the process on a PV diagram. However, I don't recommend this, okay. I recommend sketching the PV diagram after all values for volume especially is known, okay. So we can correctly locate or label, okay, where state 1, state 2 and state 3 is. Okay, so I will sketch the process diagram, the PV diagram, later after finding all the properties required. But first, and then the question asks us to determine, number 1, the final pressure during the expansion process. So the expansion process here occurs at state the second process, process 2 to 3. So it wants us to find the pressure at state 3, okay. Final pressure during the expansion process here refers to P3, and the total work in units kilojoule. So we have two processes, okay. Each process has its own boundary work, so we have to calculate it individually, and then we can add them up to find the total amount of boundary work or work done, okay, in units kilojoules. Okay, so the gas is a nitrogen. So for gases, okay, there are a few properties, okay. Since it is not given here, we have to read a few properties using the property table. Okay, so we can open table. I recommend opening table A2, but we can also open table A1, but either one, okay. So table A2, if we to open table A2, then we have to look at table A2 at 300 Kelvin, okay, not the other tables, only at 300 Kelvin, because that is the standard air temperature at which all these values are read, okay. So the values which we require are, okay, we need the gas constant R. So for nitrogen, okay, the gas constant R is 0.2968, okay, kilojoule per kgK. All right, and then we can either read for Cp or Cv, okay, Cp or Cv, it doesn't matter because we can use the relationship equation between Cp, Cv and R to find whichever we haven't read yet. So let's say we So for closed system, usually we read for CV, okay, because to find the internal energy, it's CVT. So we read for CV. So CV here for nitrogen is 1.039. Okay, kilojoules per kgK. Okay, so only these two values will be enough, okay, before we can proceed the steps. Okay, so for the first step, let's try to draw, okay, the schematic diagram. Okay, so step 1. Okay, so we have now, the question doesn't specifically say what type of system, it only says a vessel, but since there is a change in volume, okay, so it's safer to draw a piston cylinder because we allow it to have a change in volume. If we draw to a rigid tank, then the volume is always constant. So for gases, okay, so it's safer to draw a piston cylinder. Okay, so the first process is a compression process. So the location of the piston should be slightly higher than the one in state 2. Okay, so let's say state 1 is here. So we know from state 1. Okay, so from state 1, okay, pressure 800 kilopascal, volume 0.08 meter cube. Okay, so pressure 800 kilopascal and the volume is 0.08 meter cube. First process, isothermal compression. So state 2 here, piston slightly lower because we compress. Okay, so state 2. Okay, state 2, the pressure is given in the question. So pressure is 3,200 kilopascal and the volume is 0.02. Okay, so P2, 3,200 kilopascal, volume 2, 0.02 meter square. Cube, sorry. Okay, so the first process, we connect it with the process line, isothermal. Sorry for my handwriting. Okay, compression. Okay, then there's a second process, polytropic expansion. So the state 3 here for the piston should be slightly higher. Don't compare it with state 1, compare it with state 2. Okay, for just to illustrate, okay, the schematic diagram. Okay, so understanding that it's an expansion process, so the piston cylinder should be slightly higher or higher than state 2. Okay, so for state 3, polytropic process. Okay, polytropic process, the pressure is not known, it is, we have to calculate the pressure. Okay, pressure is not known. The volume, however, we know that is equal to the initial volume. So V3 equals to V1, which is equal to 0.08 meter cube. So connect the second and third state by its process, polytropic expansion. And also you can also write the index number. Okay, so n now is given, so it's quite easy since the index number is given 1.5 if I'm not mistaken. Okay, so now the schematic diagram is complete. Okay, so for step 2, okay, the equation. Okay, so step 2, okay, equation or whatever information that is required for us to solve the question. Okay, so for the first one, final pressure after the expansion process. So we know that from state 2, state 3 is the expansion process. So basically the answer asks for pressure at state 3. So this is a property at state 3. So when we find the properties at state 3, make sure we find for the pressure at state 3. Okay, for for number 2, the total amount of boundary work. Okay, so the total amount of boundary work net total is equal to the submission and the addition of both boundary work. So the first boundary work, isothermal, the second boundary work, polytropic. Okay, so we you write the equation for the boundary work. So for isothermal, it's P1 V1 ln V2 over V1. We can use also MRT, but I prefer using P1 V1 since that's the value we have. Okay, so for work 2-3, okay, for work 2-3, okay, so we have P2 now, V2 minus P3 V3 n minus 1. Okay, we can also write in terms of P3 V3 minus P2 V2, but make sure that it's 1 minus n and not n minus 1. Okay, but I prefer writing it this way. Okay, so we have both boundary work equations here, so we can solve individually and then we just have to add them up to get the total amount of boundary work. So highlight all required values. Okay, whatever is given, then it's okay. For boundary work, isothermal 1, 2, I think so we can solve for it because we have pressure at state 1, volume at state 1, volume at state 2. It's all mentioned in the question. For boundary work at state, for second process, polytropic, we have P2, but we don't have P3 because that is what we have to find in the first item. We do have V3 and we do have N, so we don't have P3, so P3 has to be find first. Okay, so let's try to find P3. But first, so for step 3, okay, step 3, the properties. So for state 1, okay, since based on the equation there is no properties that we have to find, but we still have to write them down, okay, just to make sure. So 800 kilopascal, V1 is 0.08. So just write them down. Okay, no harm done. State 2, okay, no properties required at state 2, so we can write it down, 3200 kilopascal, and V2, if I'm not mistaken, 0.02. Okay, now for state 3, okay, here is where we need to find some properties. Okay, okay, state 3, okay. Alright, for state 3, we have to find the pressure at state 3. Okay, now, first, we can try using PV equals to MRT at a state. Okay, we can try using PV MRT. But have a quick glance, is it suitable enough? Okay, how many unknowns do we have? And how many values that we have? So we don't have pressure, that's one unknown. We do have volume, okay, which is same as volume state 1. We don't have mass, but we don't have mass, it's not given in the question and we cannot calculate it. We have read for R, so we have that. So, and we don't have T3, so basically only one equation but 3 unknowns. So we cannot use this. Okay, so what's the other option? The other option is the process equation. Okay, so for state 2 and for state 3, the process is an polytropic process. So basically we can use P2 V2 index number 1.5 equals to P3 V3 index number 1.5. Okay, so we have P2, we have V2, we have V3, only remaining P3. Okay, so now we can solve for pressure at state 3. Okay, so let me get a new, okay, here. So using the polytropic equation, okay, P2 V2 1.5, okay, P3 V3 1.5. Okay, we rearrange it. We bring together pressure with pressure, volume with volume. So okay, so when I rearrange it, I like to rearrange it in terms of the greater number divide by the lower number. So if you arrange it, it's P2 over P3. Okay, P2 is higher than P3 because P3 is an expansion process, so the pressure will reduce. P2 is 3200 kilopascal. Okay, and V3 here is greater than V2 because V3 is equivalent to V1, 0.08. V2 is only 0.02. So here, and the index number is 1.5. Okay, so here we can solve for P3. Okay, so this is just basic mathematics. Okay, so we have 32,000. Okay, please try to calculate it again. I might be careless. Okay, so I hope whoever is watching can try to recalculate the value. Okay, so for P3, okay, let's try. Okay, 0.08 divide by 0.02. Okay, power of 1.5. Okay, we have 8, and 3200 divided by 8 gives us the pressure 400. Okay, so 400 kilopascal. Okay, so we have P3 that solves the first item. Okay, so now the second item is just to, the fourth step is just to substitute and solve for the question. So work net we know is the work 1, 2 plus work 2, 3. So work 1, 2 isothermal process, so ln V2 over V1, we can calculate it. Okay, 0.08 ln 0.02, 0.08. Okay, so this will give you the answer. Okay, times with 0.08 times with 800. So if I'm not mistaken, it's a negative 88.72. Okay, negative here means work is done. Okay, work in. Okay, work in, and it is correct because it's a compression process. So work has to be put into the system. So therefore, that's why work is, the value is negative. Okay, so should be okay. And then it's work 2, 3. Okay, so P2, V2 minus P3, V3, and minus 1. Okay, we have all the values. Okay. Okay, 400, 0.08, minus, and 1.5 minus 1. Okay, so here we can get, please try to redo again. Okay, so might be some miscalculation. Divide by 0.5, so we have 64 here. Okay, so positive. So positive, work is done by the system, work out. Okay, so positive means because it's an expansion process, meaning that the piston can produce and work output. Okay, because it's expanding. Okay, so the total here. Okay, so the total network here is don't forget to take into consideration the negative. Okay, so negative 88.73 plus with 64. So we get okay, negative 24.73 kilojoules. Okay, so this is the first item. Okay, I forgot to draw the PV diagram. So once we have gotten all the values, okay, so the pressure is at state 3 is 400. Okay, so when we want to sketch the PV diagram, I'll sketch it here, somewhere here. Okay, so we have the PV exists. Okay, the first process is a compression process. So high volume, okay, V1, 0.08, compressed low volume isothermal curve line, state 2. Okay, so here is the low 0.02. Okay, so this is the low pressure of 800 and this is the high pressure of 32,000. And then it goes and polytropic process. Now, which side does the line goes to? Okay, the line will go here to the right. Okay, the line will go to the light. So same volume, state 3. Okay, why does the line goes to the right and not to the left? Okay, sorry. Sorry. Okay, sorry. The line will go to the. Sorry, the line will go to the, because of the pressure. Okay, because of the pressure, the line will go towards. Cannot be towards the. The line will go towards the left. The line will go towards the left. Okay, sorry. Bit of delay there. We need to think about it. Okay, so here. Okay, why? Okay, why? First, because the index number, okay, is greater than 1. Okay, the index number is greater than 1, so it should be on the lower part. Okay, and second is because of the pressure. Okay, so P3 here is 400. Lower pressure than state 1. Okay, if we were to draw like the first time, wrong because the pressure is higher. So we have, that's why we have to determine the properties first. Don't sketch it first, determine the properties first. Okay, so this is the solution, okay, for the second portion of this tutorial question. So thank you for your attention and have a good day.